Today's question that we will be answering is how many milliliters of 0.250 molarity of sodium hydroxide are required to neutralize the following solutions. Solution A is 60 milliliters of 0.0750 molarity of hydrochloric acid. Solution B is 75 milliliters of 0.190 molarity of sulfuric acid. In order to start this problem, we must first recall what a neutralization reaction is. Most generally written, it can be written in this following form. And then this is actually an equilibrium in solution, so we can see that a generic acid with a generic base will produce two products, water and a salt. For this first neutralization reaction, we know that the molar ratios are a 1-to-1 ratio, so we can proceed as follows. We will take the molarity, 0.0750 molarity, and we know that molarity is moles over liter, and in order to proceed with this, we will need to go from molarity to moles using the volume. And in order to do this correctly, we will need to convert the milliliters into liters. So if we do that, we will get 0.060 liters. And upon doing this calculation, this will get you a number of 450 moles of HCl. So we know that in a solution containing 60 milliliters of a 0.075 molar solution of HCl will have exactly 0.00450 moles of HCl. And in order to find the milliliters of sodium hydroxide needed to neutralize this, we will take that number, 0.0045 moles of HCl, and we will divide this by the molar concentration of sodium hydroxide. And we know that the units for molarity are moles per liter. Our moles will cancel, the liters will come up to the numerator, and this will give us a number of 0.018 liters. Our answer dictates that it wants it in milliliters, so we know that there are 1,000 milliliters in 1 liter, so we will multiply this by 1,000 milliliters. Our units will cancel, and that leaves us with 18 milliliters. And let's just go back and make sure all of our units have canceled. So liters canceled there, our moles did in fact cancel, and liters canceled. So we know that we have done this correctly. For the solution B, we will do the exact same process. We will start with the molarity of 0.190 moles per liter of sodium hydroxide. Oh, actually, it's sulfuric acid, sorry about that. And we will take this and we will multiply it by 70.075 liters. Once again, don't forget to convert. And this will give us a number of 0.01425 moles of H2SO4. Let's make sure our units have canceled, liters have canceled, leaving us with moles. So we know that this is the amount of moles that is present in this solution of sulfuric acid, but we will need to take this number and multiply it by 2 in order to give us how many protons are going to be neutralized. If you're having troubles realizing why we're multiplying this number by 2, write out a balanced formula and it will come from there. And so we know that these are moles. And so doubling this number, this is what we get. And so once again, we will divide this by 0.250 moles per liter of NaOH. The moles cancel, and this leaves us with a number of 0.114 liters. And then we know that there are 1,000 milliliters in 1 liter. Our liters cancel. And this leaves us with 114 milliliters of NaOH.